Here we go. The chapter name is called Work Energy Power. Okay guys, so what is the work done? Actually, work is the dot product of force and displacement. What is the work done, guys? I have to be changed the color into black. Work is the dot product of force and displacement. That is called the work done. Okay guys, actually it is a dot product. You know what is dot product. If it is F dot S, and it would be Fs cos theta. Okay guys, and the theta is the angle between force and the displacement. Okay guys, I think you are very much aware about that work done. Next is types of work. Yes guys, types of work. Guys, we have three types of work. First one is called positive work. Guys, listen to me. If it is positive work, just imagine this is a floor that we have, and over the floor we have to be consider an object, and if you apply the force like this one to that body, and if the body that will displace in the direction of that applied force, okay, then the work is said to be positive. Okay, you are applying the force and the body will displace in the direction of that applied force, then work is said to be what? Positive. During that time, guys, W is equal to F plus cos theta is the formula of the work done. Guys, just listen to me. Here, displacement and applied force are in same direction, so angle between them should be 0, guys. Okay, so you can be simply say that work done is equal to F plus cos 0, and the value of cos 0 is 1. So you have to be consider Fs as the what? Positive work. Okay, during positive work, the displacement and the applied force are in same direction. That's very important. Okay, then next one is called negative work. During negative work, again you have to be consider this as a floor, and over the floor you please consider an object over there, and you are applying a force like this, but the body that displaces against the applied force. Okay, if the body that displaces against the applied force, if it is a force and the body that displaces against the applied force, during that time the theta, the angle will be 180 degree, guys. Now W equal to what? F plus cos 180. The cos 180 will be minus 1, so you can be right W equal to what? Minus Fs. This is called a negative work. I will give an example to you guys. When you have an object in your hand and you are throwing the object in upward direction, okay, you are throwing the object in upward direction. Okay, when you throw the object in upward direction, the work done by you means your applied force is positive. Why? Because you are giving the force in upward direction and the body will move in the direction of your force. So work done by you means the applied force is positive. But guys, every objects are attracted by earth. Let you please consider it as an earth, guys. And if the object that move in upward direction, the displacement should be in upward direction. Okay, but the same object is attracted by the earth, that is gravitational force is acting on the body in downward direction, but the body is moving against the gravitational force in upward direction. So work done by the gravitational force here is negative. Work done by the gravitational force is negative, guys. That's it. Okay, and zero work done. Only listen to me. Next one is called zero work done. Just imagine this is a table. Okay, top of the table, and over the table here we have to be consider an object. Okay, and in order to move this object, I am applying a force F, and the body will displace in the direction of that force, guys. So work done by this force is positive. Why? Because you are applying the force on the body and the body displaces in the direction of that same force. So work done by that force is positive. But guys, everyone know that the same body is attracted by the gravitational force in downward direction. Okay, the same body is attracted by whom? Gravitational force in downward direction, but the body is displaced like this. what is the angle between the displacement and gravitational forces? Just look at here, the angle between displacement and gravitational force here is, guys, 90 degree. Okay, if the angle is 90 degree, then work done W equal to, guys, listen to me. Okay, W equal to, what is that? F plus cos 90, and the value of cos 90 will be 0. So work done will be getting as 0, guys. That is the one type of 0 work. And another one example also be there. If you pull or push an object that is a stationary object like a wall, big tree, but it doesn't displace, then work done should be 0. Means there is no displacement, then also the work done should be 0. That's all about that work done, guys. Okay. Guys, a very important topic is called work energy theorem in work energy power chapter. Work energy theorem. What is work energy theorem? Guys, work energy theorem says that the change in kinetic energy is stored as work done. What is stored as work done? The change in kinetic energy will stored as work done. Let's look at here, guys. The work done, that will be equal to what? Change indicated by the delta. Change in kinetic energy, that is stored as work done. Okay, guys, everyone know that the change in kinetic energy, we have to be consider final kinetic energy minus initial kinetic energy. Okay, guys, and please write here also the work done, that is equal to final kinetic energy minus what? Initial kinetic energy. Okay, the final kinetic energy, what's the formula for the kinetic energy? Half into m into, since it is the final kinetic energy, it would be v square, final velocity square, minus, since it is the initial kinetic energy, half m u square, initial energy, initial velocity you have to be given there. Guys, listen to me here, both half m are constant. So what you have to do? You have to do one thing. You please take half m as common, then please put in bracket, and there will be v square minus u square, guys. Okay, so everyone know that v square minus u square from equation of kinematics, v square minus u square should be 2a. So you can be simply write w equal to half into m into, instead of v square minus u square, you can be write what? 2a, yes, and you can simply cancel 2 and 2, and you should get W equal to ma. Yes, guys, what is ma? Ma means mass into acceleration, the force. So you can be say W equal to force into displacement. That is a work done. This is a work energy theorem. So change in kinetic energy will stored as work done. Okay, guys. So next we have to do an important question, guys. The question is this one: an object is on the ground, its mass is 2 kg. What is the work done to move the object vertically up to the height of 100 meter? Okay, what is the thing, guys? The object is on the ground whose mass is 2 kg. What is the work done to move the object vertically up on the earth at the height of 100 meter? Okay, just listen to me. Guys, listen to me, guys. Here, initially the object is lies on the ground. Okay, since the object is lies on the ground, its initial height is 0. That's why initial potential energy will be 0. Why? Because it lies on the ground. Okay, what is the work done to move the object vertically up? Vertically up means now we have to be move the object and place it at here. It is vertically up here, and this is a final position, and here final potential energy will be there. That will be mgh, guys. H is nothing but this vertical height is called as h, but in your question the h is given there as 100 meter. Question is, what is the work done here? So work done here, the work done is equal to not the change in kinetic energy. Here work done will be change in potential energy. Final potential energy minus initial potential energy. What is final potential energy? mgh is the final potential energy, and what is initial potential energy? Here we have 0, guys. And please look at here, mass is given there as 2 kg, 2 into 10 into 100. That should be your work done, and 1000 joule is your work done, guys. Okay. Here we have another one question. What is the work done to slow down a vehicle of mass 1000 kg from the speed of 100 meter per second to the speed of 20 meter per second? What's the question? What is the work done? What is the work done to slow down a vehicle of mass 1000 kg? The mass here we have is 1000 kg and we have to be slow down the speed from 100 meter per second to the speed of 20 meter per second, guys. Okay, so guys, we need to be calculate the work done that is equal to change in kinetic energy, otherwise the work done will be equal to change in potential energy. Since here you are provided with the initial velocity and the final velocity, you must consider or you must take the work done as change in kinetic energy, guys. The work done that will be taken as change in kinetic energy, and W equal to, guys, half m b square minus half m u square, that you have to be take, and please take that half m as common, and half m again, then in bracket b square minus u square will be there. Please give these all things over here, and what is the mass there you having 1000, and the v here you having as 20 square minus u is there as 100 square, guys. By calculating you should get the answer as minus 40 into 10 raised to 5 joule, guys. That's your answer. This work done here is negative, guys. Okay, next we have to be study about the power. What is the power? Power is nothing, guys, the rate of work done, otherwise the rate of energy, that is called power. What is the power? Rate of work done, otherwise the rate of energy, that is called power. Okay, just look at here. The power is equal to work done by time. That's why I told you, guys, rate of work done, otherwise rate of energy, that is called power. And guys, we know that the work done as force into displacement. So the power is equal to force into displacement, that is divided by time. Clear? And the displacement by time should be the speed or velocity. That's why power is equal to force into speed or force into velocity, that is the power. Okay, guys, and everyone must keep in your mind, work done is a scalar quantity. That's why power also be the scalar quantity. It is not the vector quantity. Power is a scalar quantity. Work done also be a scalar quantity. Okay, guys? Yes. And one more thing about the power. We know that the work done that is equal to change in kinetic energy. So you can be right, the power P is equal to change in kinetic energy by time. Instead of work, I just keep it as a change in kinetic energy. Similarly, you can be right, the power is equal to change in potential energy by time, guys.